Okay, so this is the Tutor Wizard. What we're going to do this time is we're going to do a couple of videos back to the basics. What we're going to do is just go back to adding and multiplying fractions so everybody can stop having an aneurysm every time I try to say if I have 2 cups of flour and 7/5 of flour and I have to add them, I don't know what you're baking to have those ratios, but when I add them together, how many cups of flour do I have? What we'll do first is we'll do adding. We'll do an adding problem and I'll draw some pictures to show you what we're trying to do with adding, and then we'll do multiplying problem and I'll draw some pictures for you so that we can get a geometric insight into algebraically what we're actually doing here. Let us add 2/3 plus 3/4. That seems more reasonable. I have 2/3 cups and I have 3/4 cups of flour and I have to add them. How are we going to do this? Actually, what I do with this is my favorite dirty trick, and we're going to multiply and get a common denominator. But this is algebra and we had to invent this, so let's try to go back to the geometric picture and scenario of this and try to analyze what's happening in that scenario. I'm going to draw 2 rectangular boxes like pies or meatloafs. What it says is there, and then I cut it into thirds. I have 3/3 and it says we actually get 2/3 of that is what we're going to get. And then pictorially the 3/4 is going to be plus. We're going to get another unit sized meatloaf, but now we're going to break it into 4, and geometrically you'll see cleverly I'm going to make them into, those are all equal. It seems a little bit bigger there. Then we have, and then it says we get 3/4 of that pie. And how much pie do I get to eat if I get these weird rectangular shaped pies, not circular pies? Well, what they say is, and now let's do the clever trick, what I really like to do here is I need a common denominator of these guys. So I need a number which is both of these numbers divide. The smallest one would be nice. In this case, especially when they don't have anything in common, or even if they do at first, just multiply by the opposite number that's missing and then you'll have a common denominator. In this case, I have 3 times 4 is 12 is what I want my common denominator to be. This one is missing a 4 and this one missing a 3. So what I do is I multiply by 1 in the form of what I'm missing. 4/4. Now I have a common denominator on the bottom. And here I'm missing 3, so I multiply by 1. But that process of getting a common denominator pictorially says now we're going to get, let's algebraically do this and then I'll show pictorially what's actually happening here. Now this says when we do that clever trick, what that says is we're going to get 2 times 4 plus 3 times 3 over 3 times 4. Now that I have the common denominator, what they give us is this clever formula, and in general, this is what they give you in the book, and I don't know why they don't point out the dirty trick that we're going to use. In the book, they'll just give you, and this is AD plus BC over BD, and you're like, what? I'm going to have to memorize that, and it makes no sense as to where they got that from. This formula comes from, let's erase it for a second and see where you can actually get it from, and you don't have to memorize the formula anymore. You memorize the dirty trick, and that's the dirty trick. The common denominator of 3 and 4 is 12, so I'm just multiplying by the thing that's missing. I'm going to do the same thing here. What's missing here? D. I'm going to multiply by 1 in the form of D over D. And this one's missing B. B over B. And then this is AD plus BC. They put it in the front. It doesn't matter. You can turn those around. Those are the axioms of the real numbers. And then times BD. The rule for adding fractions is the dirty trick is what you want to memorize, not the formula. Never try to memorize the formula. Memorize how you got the formula, the dirty trick. That always happens. I clean that up now. So I have 8 plus 9 over 12, which is 17 over 12. This is how we add the fractions. Geometrically now what that's doing is, because I have this 2/3, I cut the first pie up into, it's meatloaf because it's strange rectangular pies, but we cut the first pie into 3 equal pieces and I get 2/3 of that, it says. And then it says you're supposed to get, out of the other pie I'm allowed to eat, I get 3/4 of this pie. I get 2/3 of the apple pie and 3/4 of the cherry pie. How much pie am I eating? A lot of pie. But I can't tell and I can't compare. Algebraically, what we do is we cleverly multiply by what's missing to get a common denominator. Here, what we're going to cleverly do is geometrically do this. we took the knife and we cut the pies into smaller sub-squares. And now the squares are both the pies are divided into groups of 12, the common denominator, not groups of 3 or groups of 4. And now when I'm adding these, I can see 1, 2, 3, 4, 5, 6, 7, 8, 8. This is going to be 8 squares from the first pie, and then 9 squares from the first pie. And what's that out of? I've divided it into 12. So this is going to be 17 over 12. Geometrically, this is what we're doing. And this is why algebraically you have a hard time, because they gave you some formula and said memorize that A plus B, A over B plus C over D is AD plus BC over BD. And you're like, I don't want to memorize that. You shouldn't be. The dirty tricks, there's going to be a series we do specifically on those dirty tricks, but this will be in there too, because when we add fractions, dirty trick 1 is multiply by 1 in the form of what you need. This is how we add fractions. And geometrically, this gives you a nice picture. When the pies are divided into different units, we need to redivide them and divide them into the same amount of units, and then we can tell how to add and how much pie we get. We definitely get to eat at least 1 whole pie. 1 5/12. Now we're going to multiply 2 numbers together. I'm going to have A over B, and we're going to multiply by C over D. And what the rule is, they tell you, is you can multiply straight across on the top, and you can multiply straight across on the bottom. So that's going to say, technically the move is, it's AC over B times D. Let's try to give us a geometric chop it into pies and see why that's actually true logically, of why. These algebraic things are just trying to keep track of logical things that we were clearly doing in the real world at first. And if you abstract and then teach it to where I'm just giving you algebraic rules and you have no connection to what we were possibly doing with a pie or dividing things up in the real world, you can't see why this is even making sense, and then why would you want to memorize it? It's just some witchcraft black magic that you're trying to use that some wizard has given you. That's the black arts of wizardry. We're going to shine the light on everything. First of all, what it says is, I want to multiply 2/3 by 5/7. And so the rule says, let's follow the rule. That says it'll be 2 times 5 over 3 times 7, which gives me 10 over 21. Done. Multiplying isn't that bad. What's the big deal? Why does it work out that way? What are we actually saying geometrically here? This, I can follow the formula anytime I want. What is this actually saying geometrically? What I'm going to do is I'm going to take the same pie, say, we've got, and it said I get 5/7 of the pie. 2, 3, 4, 5, 6. Not the scale. Those are close enough. And then it said I get 5/7 of that. So I get these pieces. But from that, it now says, of that 5/7, I now get 2/3 of that. So what I have to do is, I have to draw it again, unfortunately. 2, 3, 4, 5, 6. And because I'm going to start talking about 2/3, I need to break this diagram into thirds also, and we'll do that cleverly vertically. Now what it's saying is, that's why I needed a color. I dipped out again. Ah, magic. So it said I had the 5/7 was what we did first. But now it says from that 5/7, you're going to get 2/3 of that, which is going to be, well, I picked another color and then grabbed the wrong one. 2/3 of the 5/7. You could sort of ignore this piece now. Those are gone. I gave those to my brother. I had to share. And I still got 5 out of the 7. He got 2. I'm bigger than he is. No, that's not true anymore. I was at the time of pie eating. My pie. I have 5/7 of the pie. Now it says I gave the other 2/3 away, so they're gone. And now I get 2/3 of that pie, which is going to be this 2/3, and then I don't get this. So from that, I had to reshare. Here's the story. The real story is, first there was a pie. My mom made it, and she's like, share that with your brother. And I was like, okay, he can't even count yet. So I'm going to take 5/7. I'm going to give him 2/7. So I do that. So I get 5/7 of the first pie. But then I run into my sister as I try to go eat my 5/7, and then she wants a cut. So then I only get 2/3. I'm going to give her break it into what I got. I'm going to give her 1/3 of it and be like, I'm still keeping 2/3. So then I give her 1/3 of what I had. So then I only get to keep 2/3 of the original pie that I snuck out of the kitchen because I didn't really share it properly with my brother. My sister takes her third, and I only got 2/3 of that. Algebraically, what does that give me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 21 total. I erased it, but in the total square right here, we have out of 21 total squares we would have had. So the amount of pie I get to eat when I get 2/3 of 5/7 pie is 10 out of 21 pieces of the pie. I'm supposed to do that after. I'll get it right one of these times. Please subscribe below. Hit the notification bell if you want to be notified for more videos. This is the Tutor Wizard. We'll see you next time. Then mic drop.